Now we are going to discuss about the electric potential energy of a dipole in a uniform electric field. Here we consider this is a uniform electric field. In this we consider one of the dipole. This is minus q plus q. It is a midpoint of the electric dipole. Here with the electric field, uniform electric field, this dipole is placed in the uniform electric field. It is making the angle is theta. To discuss about these questions, here initially the dipole is placed, it has the angle is theta dash. Initial angle is theta dash, big day. So when the dipole is placed in the uniform electric field means, already we know, due to the charges, here there is also experience electric field. So due to the electric field there is also experience a force. Due to the force there is also experience a torque. Due to the torque, here this electric dipole, it is aligned by the torque. It is tried to align the electric dipole along the directions of the electric field. Along the directions of the electric field. The directions of the electric dipole, it is tried to orient along the directions of the electric field. Along the directions of the electric field. Okay students, are you understood what I told? So due to the charges there is experience a force. So due to the force there is also experience the force is acting in opposite direction. So there is experience a torque. This torque is tried to align the electric dipole to the directions along the electric field. So initially we take it as the angle is theta dash. So the torque is acting on the electric dipole. So it is reached the angle is theta. It is reached the angle is theta. From the concept, we are going to calculate the work done by the external torque to rotate the dipole. We are calculated by using the formula of W is equal to force into displacement. Here the force means that the force experienced by the torque is noted by the tau external. Into displacement is d theta. So here we take integral of tau external into d theta. Initially it has a angle is theta dash, finally it has angle is theta. So from this previous class we discussed about this, the tau external, it has the values is equal to, that is tau vector is equal to p vector into e vector. Here we don't know either it is positive or negative, so we can take modulus of tau external vector is equal to modulus of tau e vector, because this is done by the electric field. It is done by the electric field, so only we are taking tau electric field. It is also equal to modulus of p vector into e vector. So we can substitute in this equation. Here we can write the work done W is equal to integral of theta dash to theta. Here the tau external, it can be written as Pe sin theta d theta. Okay, so it is making the angle is theta, so we can write the tau external is equal to Pe sin theta into d theta. So from this W is equal to Pe, it will be taken outside. What is remaining? Integral of theta dash to theta sin theta d theta. Okay students, so here W is equal to integral differentiation of sin theta into t theta Pe, that is equal to minus cos theta t theta theta dash theta. Okay students, so integral differentiation of sin theta t theta is equal to minus cos theta. So lower limit, upper limit. So W is equal to, first we substitute the upper limit, mean this equation is minus Pe cos theta. Next lower limit. Lower limit means already there is having this minus, we need to put one minus, so minus into minus Pe cos theta dash. So next step, W is equal to minus Pe cos theta plus Pe cos theta dash. So here we consider at the initial position, if the dipole is placed perpendicular, if placed perpendicular to the electric field means, here we take the theta dash is equal to 90 degree. We consider at initial position that electric dipole is placed perpendicular. Is placed perpendicular means theta dash is equal to 90 degree. So that we can take the work done W is equal to minus PE cos theta plus PE cos 90 degree. Cos 90 degree is equal to 0. So we can write W is equal to minus PE cos theta. So in vector form we can write W is equal to minus P vector into E vector. Okay students, right? So from these questions we can write this potential energy also depend on the orientation of the electric dipole. Orientation of the electric dipole means theta. Okay, it is depend upon the orientation of the electric dipole. The potential energy is maximum when the electric dipole is aligned anti-parallel to the external electric field. And the external electric field, if it is 180 degree, okay, now it is opposite to the electric field. If it has the values is 180 degree, it has a maximum values. Same as here, the electric dipole, it is aligned along the directions of the electric field. When theta is equal to 0, is also having the maximum values. Okay students, thank you.